because we got a lot of questions like how would this work in a web world, let's create a project. We'll add a second project here. And we just happen to have a web Java Spring as opposed to a console. And so we'll just call this Spring Jug. And it's cloning this from GitHub here. All right. Okay, so now we have a dual project scenario going on here. Now it's downloading the jar files appropriate for this one here. So I should be able to take my build command, which is Maven, and run it on here. And it will just build, because this is also a Maven project. Boom, there it goes on that. And I'm actually going to go back and create a third project because there are some default commands that I'd like to have, and I don't remember them off the top of my head. But this is going off and building here. While it does that, I'm going to create an import project. I'm going to use my existing workspace here. And this time I'm going to get the, I'm going to grab the same one, but this time this particular approach gives us the embedded commands. All right, go back into the IDE. Good. There we go. All right. So now when I imported it using that approach, it gave me some built-in commands here. And one of them is run Tomcat. So I'm just going to go ahead and I've got a build and run down here, which is a Maven command. And I'm kind of taxing my system here at this point in time because I've got like a couple of 3 GB workspaces, plus I'm running the Che server, so this is getting pretty slow on my computer.
Does it try to keep everything in memory then?
Tries to, yeah. But you know, this is a Windows machine, so I'm actually running the Che server, and then the Che server is launching a VirtualBox VM, which is pretty taxing sort of thing. And then inside that VirtualBox VM are all my Docker containers as well. And then I've got like a couple of workspaces running in there, which each consume the RAM. So I've got some thrashing going on right now with that.
What are you actually using from Eclipse in this environment? I mean, you're using Maven, everything, to compile everything, to hook everything. What are you using from Eclipse? Just foundation classes? Or?
We use the JDT, which is all the abstract syntax analysis, and some commons libraries. That's about it. At this point in time, yeah, not a whole bunch. Yeah. So this particular command was build and run, and what this command does is it does a Maven clean install, and it then copies the ultimate WAR file in, and then I can go here and we can take a look at this, edit this command. But if we did the build and run, Maven clean install, it then copies the WAR file from the target to Tomcat home, and then it launches Tomcat with this catalina.sh run, all in one command there. And you can see the Maven just completed, and now it's launching Tomcat. So now we've got a Tomcat server running in there, And then on top of that, the last thing that it did, that it commands, was down here the preview URL. So when you have a command, you can associate a preview macro, and this basically says, this particular process that we're running, this command, is going to do something on port 8080. And what that command does is it tells Che to go find that server wherever it is inside the container and then expose its hostname and port. The port is not 8080. Even though it's running at 8080 inside the Docker container, Docker uses this thing called ephemeral ports. And so it may be exposed as 8080, but Docker maps it to a port starting at 32,768. So it's somewhere between 32,768 and 65,000 to the outside world. And so this command goes and looks that up, and here it is. You can see that the actual IP address is 192.168.99.100, which is my VirtualBox VM. And the port number of Docker that it's using is 32,783. And so if I click on that, there's my Spring. I don't know if you can see it, but there's my Spring web app. So I just created that project, I built and ran it, right? And it launched the Tomcat server inside my workspace, exposed it on port 88, and then mapped it all the way out for me to click on that preview link and go right to town on that. What's interesting, right?
That's all a beta, right?
This is all beta. Yeah, this is all beta, right? So, so if you remember, this is like a really big deal. Remember that my nightmare scenario in 2010 where I couldn't get the damn thing to run? So all this workspace, everything that we have in here, these all workspaces are defined by a JSON recipe. And we actually can take the entire definition of this workspace, the machines inside of it, their state, the projects that make them up, the source code that they come from, and define it in a JSON, and then we convert that JSON into a URL. And you can give that URL to any other person, and when they click on it, the entire workspace will be configured exactly to that configuration, including the machines and the commands and the previews as well. So now we have the ability to save your workspace as a state object, version that, and then from that versioning generate URLs that are now consumable by whomever you want to give them to. And that we call those factories. So a factory, yes?
I'm still kind of lost in this. Everything's remote, so what happens if I want to work locally?
If you want to what?
Work locally.
I am working locally on this.
Okay, so you kind of download the whole workspace.
Yeah, so Che is taking care of basically layering in the processes behind the scenes, right? So my browser, you know what might be easier to show is I have a graphic, because I knew this question was going to come up. So we'll go to the docs. By the way, GitHub star us. If you're sitting there on your computer, go to the Eclipse Che site. We'd like GitHub stars, please. There is a networking graphic here. Let's see if we can zoom in on this bad boy. Is that readable? Kind of readable? Okay, so this is Linux. We'll do Windows and Mac next. There's another layer here. You run the Che server. That's what starts up. You can run that on localhost, wherever that is, or on a remote server. Che runs on port 8080. The browser connects to Che on that port, and it says, give me a workspace. Che, inside of that, we're running Tomcat there. It says, oh, you want the workspace, that's great. It then communicates to the Docker daemon, and it says, give me a container, right? And then inside that container, Che starts a second Tomcat. We call it the workspace agent. This Tomcat is running on port 4401 and 4403 inside the container. And then on top of that, here's a secure shell daemon inside of it, the terminal. And this container 32.768 here. After this is done, booting up, the Che server says, here I am, I'm alive, and it gives it back to the browser. And the browser now knows where the workspace is. Right? So the browser doesn't have to look it up. And so now as the browser interacts with various services, it communicates directly to the container on its IP address to this port range, which then maps it to the internal services that are there. So whether all of this is on localhost, or you can put this on a machine, you can put this on a machine, and put this on a machine. You can put them on different nodes if you want, or all on one.
So, I have a question, but not directly related. I'm also interested with the browser side. You're running the IDE as a single-page application. Is it AngularJS based, or what is that?
The dashboard where we did that whole workflow, that's AngularJS. The actual IDE is a Google Web Toolkit.
Are you using AngularJS 2.0 or is it 1x?
We use 2.
2.
Mm-hmm.
So back to this.
Yep.
The Docker container, if you wanted to, could the Docker in the browser be localhost and the Che server be
Yes.
somewhere in the company?
Yeah, the Docker container, the Che server, and the browsers can be on different nodes.
Or
on one.
any combination?
Or any combination.
Okay.
Yeah. Any combination. There. There is, now if the default assumption is that they're all on the same node. Once you start putting them on separate nodes, there is special flags. You have to run Che with certain flags so that Che knows how to do things. And if you do put them on, since we assume everything is localhost, if you choose to put this and this on a different node, then this IP address has to be publicly reachable or accessible through DNS. Same thing there, right? When we install it by default, everything's localhost. There's no public IPs needed. Yeah.
And I'm assuming I can have multiple Docker containers.
Yeah, we take care of that every time.
Like having multiple like that says like Docker container, that's one workspace, right?
That's you can't see it, but there's a Docker container with a little N to the end.
Yeah.
There's a multiplier on there.
Sorry.
Yeah, I know it's a little tiny in the thing. But that's Linux. This is Mac and Windows. Che server's the same, browser's the same. Now we've got another wrapper here because Windows doesn't support Docker. So what we do is we basically go to VirtualBox to say boot a VM, and this VM is a boot to Docker VM, which is basically just an operating system that is optimized to run Docker and do nothing else. All it does is run Docker, right? So that we can get our Docker containers. So the difference here is the outside world doesn't see this container IP. This is not exposed to the outside world. What's exposed to the outside world is the Docker machine IP address. So that machine IP address represents all ports, and it does the mapping inside the containers. And we support this configuration as well.
So I'm going to put my DevOps hat and infrastructure hat on.
Yeah.
Can I have a Che server supporting the development team who wants to do local development?
What does that mean?
That means that the developer would somehow contact the Che server, but it delivers the VirtualBox or the Docker to the local host that he is calling from. And that connection then becomes there, and the Che server's no longer there, so to speak.
What you would have to do is so his question was really about exporting a workspace. And we do support workspace export and import, but there needs to be a Che server on both. So you'd have your Che server, which is the shared server, and then on each person's desktop, they'd have their own Che server, and then you could export a workspace from one and import it to the next.
Okay.
That will work.
Okay.
Okay. And then because I think there was questions about how to scale it, we also have a scaling page here in our docs. The essence is, you can either run everything on one node, so all the workspaces in Che on a single node, You could put Docker on a separate node, so you could like a huge server for Docker with all your workspaces, or you can run a Che farm. And the Che farm is, you know, you run a separate VM for each, so there's multiple Che servers on a different IP address, and then you have some sort of like Nginx router to take care of routing which goes to which Che instance on that. Or, you know, this is my company pitch, you could scale with Codenvy, and in the case of Codenvy, you know, we use Swarm to distribute the workspaces, and Puppet to deal with the configuration. And there's a way to very seamlessly go up to 1,000 nodes on that, just by add node, add node, add node. We make that kind of fun. And we've tested this up to 100,000 concurrent developers, which I'd be surprised if you did that, but you know, 100,000 is good. Okay, last part of my demo. This is truly RESTful in every sense of the word. So let me see if I can. You can't read my browser bar, but what I'm going to type here is, let's just type Swagger. And we've got a Swagger configuration inside of it. So this is the Che server itself. So we've got the REST APIs. And this is how you can programmatically control what's going on in the server if you want to. And we'll just start here with git/workspace. With the basic defaults, and we'll just execute that. And that executes a live query against the Che server, and you can see here are the workspaces that we created. So I had a workspace, it's a JSON object. It's got an ID, I'm going to copy this ID here. You can see that it's running right now. It's got an environment, and that environment that we actually used to create it, here is the machine. And actually, it was a Docker machine, and here's the script that we used to create that Docker machine. Right? So everything is prescriptive. Right? This is the workspace essential, you know, versionable configuration.
So your browser single-page application actually using this RESTful API and then getting the information?
Yeah. In fact, and all this is open source, so you can go in there and interrogate it to see how we're calling the APIs ourselves. On that. But what gets interesting about this is that there's an API for the Che server, but there's a separate API for the workspace agent on each workspace itself. So if I go in here, this URL, it's really hard to see, I apologize, but what that URL says is it says it is the Swagger of my workspace. So it actually routes through the Che server to go to the workspace and get the API from that. And if I close this, I should be able to refresh this page. Yeah, so it actually, oops, 32,780. Did I restart the, gotta go make sure I got the right port number. Extensions 32,787. 32,787. Which is the port of my workspace. So here's my workspace that I'm running, and it's got a project API inside of it. And so these are the projects inside my workspace. And so let's go get a list of all the projects for a particular workspace. So I grab that workspace ID. I will execute this. And so now this is sending a REST command directly into my workspace, and here it returns the projects that we've got on that hello world. And here's the web Java Spring jug that we just did as well, along with their commands and their properties and their attributes that are set up in there. Okay. All right. Everything inside of Che is a plugin. We are really focused on trying to build the community. We need to build an ecosystem around Che. Extensions are written in Java and JavaScript. They then are compiled into plugins, and then you can package up plugins together with the Che core and create a whole new assembly. And these assemblies are distributable. You can distribute them as a server, a zip file. We have installers. So you can create a completely custom implementation, change the UI, and distribute your own on that. So we've got lots of different plugin examples, lots of ways to create it. The plugins that you write can be 3 types. You can write an IDE plugin, which actually changes the look and feel of the IDE itself. You can write a Che server plugin, which drops into the workspace master and modifies how it works. Or you can have a plugin get dropped directly into each workspace based upon the project type. So our Maven project type is actually running inside the workspace itself. All right, getting started with it. Right now, probably the best thing to do is build from source. We have some work to do to upgrade our download servers. If you go to the Eclipse Che site, I believe that the nightly is the beta drop, but the latest release is not. Like the latest release is going to give you something that's woefully old on that. If you're doing plugin development, Che Dev is for plugin developers. And we're going to open up GitHub for issues. Please file as many issues as you want. We're in the process of exporting a Jira server with about 500 issues out to GitHub so that it's public and open, but feel free to go to town. We've got support people. And we're on IRC and it routes to our Slack instance as well on that. Get into that. All right, promotions. We have a raffle for a free ticket to EclipseCon, which would be awesome. There's also a discount code for everybody else who wants to fly out there and pay their own way. And we give away free Codenvy t-shirts. It's better than this one. It says, the actual t-shirt says, Codenvy is more instant than ramen, which I think is awesome. So just have to go to that URL and have fun with that. We'll give you some t-shirts there. And with that, yeah, I think that's it. So questions and thank you.
Thank you. Okay, we have plenty of time for questions, so please.
Are you tied to Maven specifically, or why did you choose Maven over Gradle?
We, it's not that we chose Maven over Gradle, it's that we built the system in Maven. So the first plugins that we built were Maven. Instead of trying to have a bunch of different plugins that are very thin, we're trying to build a superior Maven plugin as a kind of a reference case of handling the most complex scenarios. There's actually all sorts of stuff we got coming. One of our top engineers, he's about to just push out a new Maven plugin, and actually it has inside of the IDE intelligence about the object model, and we can start doing things like rewriting the modules, rewriting the POM, and stuff like that. So that's been our focus, because we have to pick one and kind of go deep to exercise the IDE on it. And we really have to work with the community to help us build out the rest of it. We've got an AMP plugin as well, I just didn't show it here. Yeah. Yeah, please.
How hard is to implement a plugin or an extension to support new language you don't support by default?
Yeah, so that's a good question. So how hard would it be to support a new language? I think that it's a very open-ended question because supporting a language has a huge spectrum of possibilities on it. So let's take it from the most minimal spectrum, which is that you need really 3 things. Syntax, highlighting, compiling, and then execution or interpretation on that. So if you can do those 3 things, then technically you minimally support it. If that's all you want to do, there's a very thin amount of work that you need to do because the compiling and the running is defined in a stack. And the stack is just Dockerfiles that you add as a configuration file to Che. So you could just write that and get going with it and you're ready to go. The syntax analysis is also equally easy because Orion defines a syntax file, and so they support dozens already, and you can add your own syntax file for a language there. So on that basis, you don't even have to write a Che plugin, you're just basically configuring Che. On the other end of the spectrum, you're doing like what we're doing here, where you've got We modify the project tree based upon the project type. We actually register a project type. There's a Maven project type. There's a wizard for whenever there's a Maven project, we take you through a wizard for configuring that. Then there's the Intellisense, where we're doing the Intellisense services. So you can layer in as much work as you want to do. The process of writing a extension it's in Java. We use dependency injection to write the extension. And we use Gin and Juice, which is Google's dependency injection for that. And so essentially you write extension classes, you write dependency injection to configure how that extension class should work, and then you package it as a jar, and the jar deploys inside the Che. It's pretty simple to get going. We've got a great tutorial. It's really nice getting started tutorial. Doing the hello world is great. It's easy. Incremental build, and then getting as sophisticated as you want to get is then onto you at that point in time. But you've got a lot of things to decide, like what stuff are you going to put inside the workspace, what things are you going to keep inside the Che server, because you're distributing these services here. Yeah.
Did you also say that, for example, the autocomplete, that was happening over the REST call?
WebSocket call, yeah.
So basically everything as far as the JDT and all that analysis.
It was all server side.
So how difficult would it be to take the existing plugins for Eclipse and convert to older?
We get that asked all that time. Well, it's certainly, the data model is going to be kept just fine. The issue that you're going to run into is when the UI is not compatible between the Eclipse at all. Because Eclipse plugins are SWT and here it's GWT. So the UI is going to be a different paradigm on that. But a lot of the data model and the core services, for the most part, are going to be left alone. The work that we did is we forked the JDT and left it unchanged. And then we had to do two parts. We had to write a RESTful wrapper interface around it, and then we had to do our UI that was specific to that, and that's how we did the work ourselves.
That's actually what I wanted to ask as a follow-up. You can expose any RESTful API, but then the UI part would not be able to understand that until you actually implement
Yes,
those endpoints. Right?
that's right. That's right. Yeah.
So, what's your role in comparison to Eclipse? Is it like next generation Eclipse? Is it phasing out Eclipse? Is Eclipse being developed parallel to this?
The Eclipse IDE is still maintained. There's about 10 or 15 developers that still maintain the Eclipse IDE. But its roadmap, like if you go and look at its roadmap, it's almost exclusively to language enhancements. So it's either bug fixes or say like Java 9 support. But the IDE itself and its approach is not fundamentally changing here. My company, Codenvy, we're about 80% of the committers right now, but we have committers on this project from IBM. SAP has like 4 or 5 committers. Microsoft is involved, which is not something you hear associated with Eclipse too much. IBM is involved. Red Hat is a big contributor to this. So we've got some pretty impressive vendors. What my company does, beyond the just scaling it normally, this is a site that we haven't put up yet, is we take all this and then we create a better Agile workflow. And what we mean by that is, in addition to being able to have these workspaces, we provision them completely on demand. And we provision them in a way that it's integrated to your issue management and CI tool chain. And so actually what happens, and we call this a better Agile sort of workflow. But what we do with that is we basically make it possible for any person to get a workspace off of any issue at any point in time without them having to deal with the branch flow. And the essence of the way that works is, and this is kind of a previous generation, we use Jira internally, And we basically install a plugin to Jira or Microsoft Visual Studio Team Services. And what it does is it modifies the issue. And behind the issue, we have a Che workspace definition there. And then that workspace definition gets translated into a URL. This is the factory. So I, as an anonymous user, when I click on this, it will take care of the branch. It'll set up the branch if necessary on that. If the branch is already set up, it will then create a workspace, and it either creates the workspace per user or per issue or per whatever policy you have it. And then after the workspace is created, it generates it according to that whole spec, including the projects and the commands and whatnot, and then puts the user inside of it. And then the user can do his development. He commits directly within the workspace to the branch or to a pull request, and then the workspace is destroyed and cleaned up. So the developer, what Codenvy sells is basically, look, you just keep using issue management. We will blend in directly to issue management wherever it is, and we take care of all the branch flow and all the workspace generation, and you can have as many workspaces as you want. You can have tens of thousands of workspaces per task, per issue, per user, per team, and you just get to work and get done with it. Here. Yeah.
We had a talk with Paul about no-ops before we started it. What are your thoughts about continuous deployment and creating test environments and distributed systems?
Continuous deployment. Continuous deployment is it's a function of culture on that. Codenvy itself, like we have tried to get to that point, but it is very difficult. When we do a release, we have codenvy.com, which is a live hosted SaaS, and we have on-prem software, which is tagged and released software that gets installed in customers. So this idea, what does continuous deployment mean for us?
I was more referring to using the tool as a tool for continuous deployment as well as the developers. Because you're so integrated with Docker and can create environments for testing and for production and
yes.
whatever you want to release it.
So that's a different question. Yeah, so we have this, I think that Docker has come around and really advocated a philosophy of what I call topological parity. And topological parity is this idea that your production container topology should be identical to your development or test topology that's there. And I don't see any reason why that's not the case. But it starts by you have to have your workspace honor that topology identically. And I definitely agree with that vision. And we'd like to get to the point where the workspace topology is a direct reflection of the production. Now it's a little bit trickier than that because our topology, even though we can take the base topology, we're installing all sorts of other stuff to be able to do a debugger, to be able to do the secure shell, and these are sorts of things that you never want in production. So you have to have parity, but then you have to have variations on that. But if we can get the parity and then have the variations be the bare minimal set, we're certainly going to be a lot more productive as an industry because now essentially the DevOps guy is just responsible for making sure that the configuration is as minimal as possible on that. Yeah. All right, I think that's a good wrapping up point. So guys,
cool.
Thank you so much for today. This was awesome. I'm actually glad this went as well as it humanly did. How many of you are willing to try it out? That's awesome. File issues. Please file issues. The engineers will love you for that. They really will on that.
Thank you
so much.